Hi friends, we are looking at an interesting problem from number theory. The problem is this. There is a number given like 2 to the power of 9 multiplied by 3 to the power of 8 multiplied by 5 to the power of 11. We are asked to find out the least value of another natural number with which this is to be multiplied so that it gets converted into a perfect cube. So the first thing to have a clear idea about what exactly is a perfect cube. I'll write it here. Any natural number in the exponential form with the exponent or index being a multiple of 3. This is the meaning of a number which is a perfect cube. For example, 2 to the power 12. See, this can be written as 2 to the power 4, the whole raised to 3, using the law of index. Or another example, say if I write 4 to the power 300, you can write it as 4 to the power 100, the whole to the power 3. The moment you hear a perfect cube, we think of something raised to 3. It's not exactly raised to 3, even other numbers. So the definition is index or the power has to be a multiple of 3. So there are so many other examples which you can see. So let me generalize the definition. Given a big number, say supposing you are given a natural number n. As you know, every natural number is expressible in the form a to the power of p, b to the power of q, c to the power of r, where a, b, c are prime numbers and p, q are positive integers or natural numbers. As you know, positive integer and a natural number refer to the same numbers, just 1, 2, 3, these whole numbers without 0. Now look at the number given to you. It's already in this form. There is a name for that. This is what we call prime factorial form, this format. Given any natural number, you can uniquely express this number in this format, and that's what we call prime factorial form. See, for example, I'll give you a few examples before proceeding further. Take 100. This can be written in the form 2 squared, 5 squared. Look at the base figures 2 and 5. They are prime numbers. And the powers can be just a positive integer. Now take another example. And what, by the way, is this a perfect cube? No. Perfect cube means all these integers, they will be either 3 or multiples of 3. So this is clearly not a perfect cube. Now take another number, say 216, which is actually 6 to the power of 3. This itself shows this is a perfect cube. If you want to write this number in the prime factorial form, that will be 2 to the power 3, 3 to the power 3. Okay, if you look at this number, see, you have only 3. So it doesn't have to be 3. It could be 3, 6, 9, anything. So this is a perfect cube, whereas this is not a perfect cube. Now take the number given to you, which is already in the prime factorial form. See, this is the number given to you, and you are asked to find out the least number by which this should be multiplied to convert this into a perfect cube. So the first step is to write, see, 2 power 9, already a perfect cube. We write it as it is. 3 power 8, let me write like this. 3 power 6 multiplied by 3 power 2, and 5 power 11 we will write as 5 power 9 multiplied by 5 power 2. This is based on this rule of index. A to the power n multiplied by a to the power n equal to a to the power m plus n. I have used this to split 3 power 8. See, 3 power 6 multiplied by 3 power 2 will be 3 power 6 plus 2, and that will be 8. Similarly, 5 power 9 multiplied by 5 power 2 will be 5 power 9 plus 2, which will be 11. So we have just modified the given number like this. Now in the next step, let me write 2 to the power of 9 as it is, 3 to the power of 6. Then let me choose 5 to the power of 9. Then this 3 I will write here, and there is a 5 here. Now the given number we have modified into this format. And if you look at these different terms, See, given number has three terms. I have split up that into five terms. If you look at the first three terms, they all have multiples of three. That means this part is a perfect cube. Now you have the 3 squared multiplied by 5 squared. This part, if you can bring 3 here and 3 here, then the whole thing will be a perfect cube. But how do you bring 3? All you need to do is just multiply this number by 3 multiplied by 5. I'll write this number. This is something I have used as a multiplier, and you're getting converted that into 2 power 9. This I am writing as it is 3 power 6, 5 power 9. When you multiply this 3 squared by 3, you will be getting 3 power 2 plus 1, which is 3. Similarly, 5 squared into 5 is 5 power 2 plus 1, which is 3 again. Now look at this number. Every term has multiple of 3 as its power or exponent. So this has become a perfect cube. For that, the given number is multiplied by this number, 3 multiplied by 5. So 15. 15 is the answer to the question. Rather, 15 is the least number with which the given number, which was this, to be multiplied to convert that into a perfect cube. See, this is not the only number. I'll show that in the margin. In fact, there are many multipliers, infinitely many multipliers you can find out. The next one I will show you. I'm rewriting this number. 2 power 9, 3 power 6, 5 power 9 multiplied by 3 squared, 5 squared. This is the given number. Let me multiply by this with 3 to the power of, say, 4 and 5 to the power of 4. If you take this 1, what do you get? When you multiply this by this number, these numbers I'm writing as they are, then 3 squared into 3 to the power of 4 will be 3 to the power of 2 plus 4, which is 6. Similarly, 5 squared multiplied by 5 to the power of 4 will be 5 to the power of 2 plus 4, which will be 5 to the power of 6. So ultimately, you are getting 5 terms with each term having exponent being a multiple of 3. That means this is a perfect square, and this is the next multiplier or one of the different multipliers. But anyway, 15 is the smallest, so the answer is 15. The point I'm trying to make is this: 15 is not the only multiplier. You have infinitely many multipliers using which you can convert the given number in the prime factorial form into a perfect cube. That's all. Apart from solving the problem given to you, I have introduced you to a few simple concepts in number theory, which would help you a lot in solving many other complicated problems in number theory. And if you have followed the solution correctly, please hit the like button and subscribe to my channel and share this video with others who might also benefit from this. If you want to keep watching my videos, please hit the bell button. Thanks for watching and see you in the next video.